So our next topic here is albedo, where we are thinking about how albedo affects climate. And of course, before we can dig all the way into that question, we have to know, well, what is it? So you've already got a little bit of background by completing part 1. If you haven't yet completed part 1, you should go back, read through this very short article highlighting what is albedo and also examples of both high and low surfaces. And then there was a short little question section for you to do by just circling higher or lower for both the pictures and the sentence. So let's just do a quick recap here. What is albedo? Albedo is kind of a crazy word, but it's something pretty simple. It's measuring the percent of solar radiation reflected by a surface. So we know the sun shines down onto the earth, and there's many different surfaces that cover the earth. This is a great picture just showing water, ice, or land, and then also clouds, and how the sun's energy acts differently in countering each of those objects. Same thing over here with different colored surfaces. Light comes into, say, dark, medium, and light surfaces and reacts differently. Here you can see all the light going right into the dark surface and being absorbed. If it's a little lighter, some is reflected, and here if it's a lot lighter, we see more reflected. And that's exactly what albedo is measuring, light reflected. So we're going to draw an example here, keeping in mind our focus is about light being reflected. And we're going to do that for both high albedo and low albedo. So we're just going to draw some land here, a surface, and we have the sun. And we're looking at how much light is being reflected again. So in a high albedo situation, we have a large percentage of the light coming to the earth being reflected, which means a small percentage of that light is being absorbed. On the same side over here, we're thinking low albedo. Again, light is coming to the Earth's surface and is being reflected. In a low albedo surface, that number is small, meaning a large percentage is being absorbed. So we want to come up with just a couple examples down here at the bottom. Surfaces that tend to have a high albedo and reflect a lot of energy are surfaces like snow, ice, sand, right? They are all light colored surfaces. Whereas over here, a low albedo reflects a little, absorbs more. These are typically the dark colored surfaces, and they, because are absorbing a lot of energy rather than reflecting, they often heat up faster as well. So like asphalt is a great example, right? Dark colored like driveway, forests or trees, and let's see, how about like grass? Okay, those are lower albedos. So on average, the Earth has an albedo of 31%. So that means all the surfaces combined for their albedos is right around that 31%, which means the Earth is either reflecting or absorbing more solar energy. So again, thinking about that albedo is measuring energy reflected. We know that's a smaller number. So the Earth absorbs a lot. And it absorbs a lot because, looking at our picture and just knowing what we know about the Earth, it is mostly ocean. Ocean is one of the lowest albedos, right around 6%. So you are going to be doing some data collection here in your part 2, finding some albedos and then finding some light reflected numbers and calculating for albedo. And it's a simple percent measurement. So what we have to do is take lux reflected, okay, so the amount of light reflected, divided by, I don't like this there, divided by lux received, and simply multiply that by 100. So you're looking at your data table right now, and you'll notice that all the light received is already set up for you at 3,500 lux. That's just an average amount of solar energy coming to the Earth every day. So every single surface is getting exposed to the same amount of light coming at it. What we want to take a measurement of is how much is being reflected. And so you have a long list there. You're going to be looking at this diagram. And this diagram here is listing out a lot of different surfaces and how much, again, they reflect. Okay? So the first one we're looking at here, or looking for here, is sea ice. So we're searching around, snow, soil, grass. Here it is, sea ice, 2,100 lux. So that's how much light this surface is reflecting. So I need to plug that into my simple calculation. 2,100 divided by the amount of light coming in, 3,500. And then I'm simply going to multiply that by 100. And it's important we always do it in that order, right? We don't want to put the bigger number on top. That doesn't work mathematically. And so this one works out to be 60% albedo, right? Reminder, this is never going to be over 100%. And then you did your calculation wrong. Okay? So 60% for sea ice. Then you're going to go back to the map, find water, plug that in, dividing it by 3,500, and multiplying that new answer times 100 will give you your albedo percent of light reflected from that surface. So here's all the different surfaces that you're going to be finding in that diagram. Go ahead and pause the video now so you can collect all of your data and calculate. The last piece that you have is just to pull everything together here, do a little summary of your findings. So looking at your data, list out the highest top 3 surfaces. So here you can put in whatever that surface is along with the percent. And then pull together just a quick summary, finishing the sentence using the keywords that match for the high albedo, either light or dark, reflects or absorbs. So these surfaces are high albedo because, finish the sentence here using those keywords. Same thing on this side for low albedo, give the top 3 surfaces with their percentages, and then finish the statement, surfaces are low albedo because, using the keywords that fit. Your part 2 is done. Hang on to it and wait for the next step.